Hello friends, you are welcome to another session on Code with Matt. If you are yet to subscribe to this channel, kindly hit the subscribe button. And if you like what you are watching, please like my video, share this video with your friends, and help more people to discover these videos. Thank you very much. We have been looking at learning C programming language, and we have started the topic understanding operators in C. Understanding operators in C. So we have looked at the definition, we've looked at different classifications, and we've considered the arithmetic operators, we've considered the relational operators, we've also considered the logical operators. If you have missed out on these videos, please kindly check through the channel and you would be able to see the video. Or if you are following on this present playlist, just go back 2 videos away and then you'll be able to see the beginning of the videos. Today we are going to continue and we are going to look at bitwise operators. Bitwise operators. For us to understand bitwise operators, we need to return to the concept that our values are always stored in binary form in the computer, because the computer only understands binary. So our values are always stored in binary form. And also we need to also understand the number of bits. So bits are the smallest storage unit, right? A byte can only take a single binary value, which is either 0 or 1. So bits are the smallest unit. So 8 bits make up 1 byte. So when we discussed data types, we understood that a char, for example, is stored in 1 byte. An integer can be stored in 2 bytes or 4 bytes, depending on your architecture. And then the long can be stored in 8 bytes or 4 bytes, depending on your system architecture. So understanding this, we will now know that every number we store is going to be stored as zeros and ones in those memory locations. So for us to perform bitwise operators, we will manipulate the binary values stored in the different bits of our value in memory. So there are different operators. The first one here is the binary AND operator. It's also it's a binary operator, means it takes 2 operands, and in the operands it compares the values. It checks the values at the bits of those operators. It checks the values at the different bits of its operand, right? And then in those bits, it checks if they are both truthy or falsy. If they are both true, that means if both values are 1, it returns 1, right? The result at that bit will be 1. If both values are 0, the result is 0. If either is 0, the result will still be 0. So it does that for every bit that of the values. The binary OR, also similar to the logical OR, it checks each bit. If either bit is 1, returns 1, and if no bit is 1, returns 0. For the binary XOR, which is also known as exclusive OR, in this one it checks both bits. If and only if one of the bits is 1, will it result in 1. However, if either bit is 1 or either bit is 0, if both bits are 1 or both bits are 0, then it will result in 0 in that particular bit. The next is the complement operator. It's a unary operator, and what it just does is it flips the bit. It flips the bits in it flips the bit of the value that is passed into it. So if a particular bit is storing 0, then it results to 1 in that bit. And then if a particular bit stores 1, then it returns 0 in that bit. Then left shift operator and right shift operator. For left shift operator, what it just does is it moves the bit leftwards and introduces 0 at the rightmost end. So it does that until if it gets to the end, that means if 1 gets to the end, that 1 gets popped off and 0 gets inserted. Right shift operator actually does the same. It's the opposite. It moves rightward, right, and introduces 0 at the leftmost end of the bit. So it could shift everything off until all the bits become 0. So for more of this, let's check them out in our VS Code. Okay, for a better understanding of this, I would want to create a new file. I can get rid of all of this. I'll create a new file. So let's just do a boilerplate, right? So include stdio.h. So let's have two integers. So int a, let a equal to 6. Int b equals to 7. So of course we have to end with semicolons. So let's do a, let's have a new integer to store the result. Int c equals a, let's do a binary and b. So of course let's call our printf %d with a new line. Of course we are printing c. Okay, so let's see gcc bitwise.c output bit. Okay, so let's run bit. So you can see the result is 6. So a and b, the result is 6. For us to understand what is happening here, I'm going to use an Excel file, and in this Excel file I'm going to try to define what is happening. So our first integer is a. So a was given the value of 7 of 6. Sorry, A was given the value of 6. And then B was given the value of 7. So if you understand binary conversions, right? So you would know that A has yes, 6. So 6 has the following, right? So 6 is 1, 1, 0. And of course 7 is 1, 1, 1. So let's just have this A, B. So the operation we are performing, so let's this be C, right? So let me just, for us to understand, right now we are performing the hand operation. We're performing the hand operation. So the hand operation, again, the hand operation compares each bit. So we start from here. It compares both bits, right? So it returns 0 if none of them is 1, or either of them is, if either of them is 0, it returns 0. Let me just put that there. So if both are 1, returns 1. If either is 0, returns 0. So here we return 0. So here both are 1, so this will return 1. And both are 1, this will return 1. So that's 0, 1, 1. 0, 1, 1. 0, 1, 1. So if we reverse that, that's 1, 1, 0. So 1, 1, 0 is the value of 6. That's why we get 6 back. So we can then come here. Let's put our value here as 6. Okay. So coming back to our code, we could have another operation, right? We could have the logical OR operation. So in the logical OR operation, let's see what the result would be. Sorry, in the binary OR, we get 7 as a result. So let's go back to, let's see how this works. So right here, OR, right? So in OR, it checks each bit, right? So 0, 1, 0, 1. So remember OR, if either of them is 1, it will return 1. If neither is 1, that's when you get 0. So 0, 1. So of course, this will be 1. Oh, sorry. I should do it on a new line. So of course, this will be 1. And here, they are both 1. So of course, this will be 1. And here too, of course, this will be 1. So we get 1, 1, 1. 1, 1, 1 is 7. So here is 7. So let's go back to VS Code. We are going to change this to, let's use the exclusive OR. It may be difficult to find this exclusive OR on your computer. However, on my computer, the exclusive OR, this upward angle, is actually, I actually got this using Shift 6. That is what is on my own computer. If that is what is on your own keyboard, I think you can just use that also. Okay, so let's compile our code. Let's run it. Okay, so exclusive OR returns 1. Why is it returning 1? Let's go back to our table.